What is the Heisenberg uncertainty principle? There is, of course, an equation. Heisenberg wrote, "It can be expressed in its simplest form as follows. It is impossible to determine both the position and speed of a particle at the same instant." Quantum physics offered different explanations for the uncertainty principle, the wave and matrix mechanic picture. Finally, everyone says that it is indiscernible on the macroscopic scales that humans experience. In other words, humans cannot see this effect. So here's our list. Let's look at the uncertainty principle in the macro-human world, which is not supposed to be possible. I got this box off eBay and built a contraption inside the box, which I'm not going to show you just yet. I drilled 2 holes, one on either side, and placed 2 cameras, one a new digital camera and the other quite an antique. I'm remotely triggering an event within the box, which will cause both cameras to take pictures at exactly the same time. There. Here's the first picture from the digital camera, and we can see a baseball. From this picture, we can clearly see its position. We know just where it is from this picture. Alright, the picture from the older camera is now back from being developed. Let's have a look at it. Oh boy, doesn't look quite the same. You see, inside the box, the baseball was released and rolled down the slope. When it reached the middle, it depressed a switch, causing both cameras to snap a shot. So again, do we know where the ball is? No, I'm afraid that's where the shutter was open at its widest point, collecting the most photons. If we get rid of that advantage and make them look all the same, do we know where the ball is? Not at all. However, we can very precisely determine its speed and velocity. To do this, we need the length of the picture, the shutter speed of the camera, and then we need to measure the distance between the blurs. With a little math, we can come up with the exact speed. We can also determine the velocity by measuring the variation between the motion blurs. So from one measurement, the newer digital camera, we got the position but not the speed. From the other measurement, the older camera, we got the speed but not the position. But we could not get both position and speed from either picture. Check. What about the wave and matrix mechanics? No. What about the quantum weirdness, something that can't be seen by normal humans? Again, no. But wait a minute, scientists don't use old or newer cameras to measure the position or speed of subatomic particles. Let's look at that. It's said that you can only see the uncertainty principle at the quantum level because at that level things are more like waves. Oops. Particles are fired from various instruments, and measurements are done using instruments like Geiger counters, chambers of gas, or EM fields. Here we're going to fire a particle at the detector and get its position, and at the same time when the particle is fired and when the particle hits the detector, and get its speed as well. Let's see what that looks like. The particle is fired. From the particle's point of view, it looks like itself, but because of its near-light speed, length contraction causes the room, and in fact, the entire universe, to contract in the particle's direction of travel. Now that's quantum weirdness. To us, the universe still looks normal, but the particle pancakes in the direction of travel. You can't get rid of length contraction. It is detected by the detector, and voila, we've got both. Yes, you have the particle's position here. But as soon as you think speed, the position is lost. During the speed measurement, position doesn't exist. At least for myself, at this point, it seems utterly easy, and I should have just started with this. When something is still, it has a position, and speed doesn't exist because it is standing still. When something is in motion, position does not exist because it is constantly moving and it has no position. Seemingly a 4-year-old experiences the uncertainty principle. I've looked at this a long time, and what I presented seems solid enough though too ridiculously simple. Far greater minds than mine have exalted this uncertainty principle for 70 years or so. So yes, I'm somewhat uncertain. If I'm totally off base, I hope someone points out why. I greatly appreciate any feedback and thank you for watching.